Okay, students, good noon. Today, in the continuation of electrochemistry, after a long term, we are going to discuss electrode potential. So, what is electrode potential? Is that the tendency of an element that will be discussed here. So, I am going to narrate those points which are essential about electrode potential. So, electrode potential is number one, a tendency, tendency of an element, tendency of an element when placed, tendency of an element when placed in its own ion, tendency of an element. Number two, when placed of its own ions. Suppose this is a container and there is a zinc element, zinc element, or you can call metal, zinc metal, and this is placed in zinc sulfate solution. Zinc sulfate solution. So this zinc and this zinc sulfate, the zinc is a common ion. Zinc Zn ion is a common ion. So electrode potential, a tendency of an element when placed of its own ions in either, then what happens there, we will write either lose or gain electrons, either lose or gain electrons. Suppose there is an copper metal, Cu metal, and it is placed in CuSO4 solution. So here copper ion, common ion, copper ion or common ion. So electric potential is a tendency of an element when placed, when that element is placed of its own ions, placed in its own ions, you can say they either lose or gain electrons. They either lose or gain electrons. In turns, what happens in turns becomes, becomes positively or negatively charged, positively or negatively charged, positively or negatively charged. So this electrode potential is a kind of tendency of an element when placed placed of its own ions, when placed in its own ions, you can say they either means this element either lose or gain electrons. And in terms of lose and gain electrons, it becomes either positively or negatively charged. Suppose if there is M solid, this is metal, and in turns it lose electrons, n plus n electrons it is losing. And in other words, you can say m m n plus ions. After getting n electrons, it converts into n solid metals. Then what happens? There is the loss of electron. There is taking place loss of electron, and here it is taking place gain of electrons. Gain of electrons. So when there is the loss of electrons, it is called oxidation. It is called oxidation. And when there is gain of electron, this is called reduction. When it is gain of electron, that is called reduction. So a potential which is different, this is called oxidation potential. This is called oxidation potential. And this is gain of electron, this is called reduction. So this is called reduction potential. This is called reduction potential. So there are electrode potential is of two kinds. One is oxidation potential. One is oxidation potential. One is oxidation potential, and another is called reduction potential. Reduction potential. And together, both are called electrode potential. Both are called electrode potential. So here I would like to say, here I would like to say that both oxidation and reduction potential both are equal in magnitude. Both are equal in magnitude. Oxidation, oxidation, oxidation potential and reduction potential. Oxidation potential and reduction potential both are equal. Both are equal in magnitude. Both are equal in magnitude, but opposite in sign. Both are equal in magnitude, but opposite in sign. Both are equal in magnitude, but opposite in sign. It is not a thermodynamical property. 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 It is not a thermodynamical potential. It is not a thermodynamical property. And value of E are not additive. Value of E, value of E, value of E, I mean electrode potential, value of E are not additive. Value of E are not additive. And one property I would like to say, reduction potential increases with increase in concentration. Reduction potential increases. Reduction potential. Reduction potential increases with increase in concentration. With increase in concentration. And reduction potential decreases with decrease in concentration. Decrease in concentration. So here I would like to say again that electrode potential is of two kinds, that is oxidation potential and reduction potential. And this oxidation potential and reduction potential is a tendency of an element. This is the tendency of a zinc. In case of zinc sulfate solution, zinc changes into Zn2 plus ions and losing two electrons. In a similar way, copper changes into Cu2 plus ions, including two electrons. Or if zinc and copper both are two electrodes, so in this case here what happens? Cu2 plus gaining two electrons, and this is the plus ion. As earlier I have discussed it here, that is zinc dissolved in the solution and the rod of the copper is deposited and becomes thick and thick again until and unless the fully zinc electrode is not dissolved completely, then the cell stops working. So this is electrode potential, that is oxidation and reduction potential, that is a potential developed. This is a property of an element. When that element is placed in its own ions, either it starts losing electron or it starts gaining electron. And in terms of losing and gaining electrons, either it becomes positively charged or it becomes negatively charged. But both the charge that is called the electrode potential are equal in magnitude but opposite in sign. So I would like to say you all the students that you have to note down all these points in your notebook and you will have to learn about this topic. Now now in the second case I would like to refer here SHE, that is fully called standard standard hydrogen standard hydrogen electrode. Standard hydrogen electrode in abbreviated form we can write SHE. In abbreviated form we can write SHE. First of all, I would like to draw its diagram. So there is a tube and that tube is opened here from here it is closed vessel and from here there is a platinum wire and that platinum wire is it ends with the platinum white coated with platinum black and from this opening there is a passage of hydrogen gas and 1 bar pressure and 1 bar pressure temperature there will be 298 Kelvin and this whole is placed in a container where this gas is bubbled like so and there is this placed in a 1 molar HCl solution. 1 molar HCl solution. This is platinum foil coated with platinum coated with platinum black coated with platinum black. This is standard hydrogen electrode. This is standard hydrogen electrode. And what are the basic points of the standard hydrogen electrode? Number one, I would like to discuss here. First of all, this is a kind of reference electrode. This is a kind of reference electrode. This is a kind of reference electrode. This is a kind of reference electrode and it can be connected with any electrode. It can be connected with any electrode and its reduction potential. Its reduction potential is always reduction potential, and its reduction potential arbitrarily its reduction potential arbitrarily assigned arbitrarily assigned as zero. Its reduction potential arbitrarily assigned as zero. There is a you know that there is a platinum there is a platinum coil connected with a wire connected with a platinum wire, and that is coated with platinum black. That is coated with platinum black. And the electrode dipped in 1 m H plus ion concentration solution. And this electrode is dipped in 1 m H plus ion concentration solution. I will go in 1 m H plus ion concentration solution. And there is a passing pure hydrogen gas. There is a pure hydrogen gas. Pure hydrogen gas is passed through it at 1 bar pressure and temperature in Kelvin 298 298 Kelvin. And the most important property of this electrode is it can act as both. It can act as both oxidation. It can act as both oxidation or reduction. It can act as both oxidation or reduction. Oxidation at anode and reduction at reduction as in cathode. As in cathode. It can act as both as oxidation as anode and as reduction as in case of cathode. It can act as a both. When anode, in case of anode, it will act as S2 will be S2 will be converted into US plus by using two electrons. And in case of cathode, it will act as reversed condition. It will act as a reverse condition. So it is standard hydrogen electrode, and this standard hydrogen electrode is acts as a reference electrode. It can be connected by any other electrodes because its potential arbitrarily assigned as zero. So we can calculate the potential of another electrodes. And the structure of this standard hydrogen electrode is in front of you as I designed in the blackboard, and the important points I summarized here in the blackboard, and I hope that you have noted all these things. How would how would we represent this cell? How would we represent this cell? So this cell can be represented as like this: platinum solid hydrogen, platinum solid hydrogen gas, platinum solid hydrogen, and here you can write gas, platinum solid hydrogen, you can write gas H plus equals here H plus plus ion. We can represent this like this. We can represent, we can uh, like this, we can represent like this. So I hope that you will have noted all these points. Now I would like to erase this and proceed towards the next topic. Now, standard electrode potential. Before earlier, I have discussed electrode potential. That is differentiated into two kinds: oxidation potential and reduction potential. Then I have discussed about the standard hydrogen electrode, which reduction potential arbitrarily assigned to zero. Now I am discussing about the standard electrode potential. Here I would try to note down standard electrode potential. Standard electrode potential, and you can represent it as easy. Standard electrode potential determined relative to standard hydrogen electrode. Determine this standard electrode potential is determined relative to standard hydrogen electrode. As earlier I have discussed standard hydrogen electrode. In connection with that standard hydrogen electrode, we can determine the electrode potential of any electrode, that is known as standard hydrogen electrode. Under this determination should be under standard condition. This electrode potential should be calculated under the standard conditions. What are standard conditions? Conditions are 1 bar pressure should be 298 Kelvin. Temperature should be 198 Kelvin. Temperature should be, and 1 molar 1 molar concentration of 1 molar concentration of each ion. 1 molar concentration of each ion. So when we calculated the electrode potential of any electrode in connection with the standard hydrogen electrode under the standard condition, under these standard condition, we will call that electrode potential is standard electrode potential, and that will be calculated. So you know about the importance of standard hydrogen electrode. You know about the importance of standard hydrogen electrode, and you know about the importance of standard electrode potential, and you know about the electrode potential. These three topics are very essential. Now I think you can differentiate in this condition what is electrode potential and what is standard electrode potential, and what is the importance of standard hydrogen electrode in calculation of these two. Now now we are going to proceed about cell potential. Now we are going to proceed about how we are going to proceed about self potential, or in other words, we call EMF or the self, EMF of the self. The full form of EMF of the self is electromotive force, electromotive force, electromotive force of the cell. This this cell potential, this cell potential or EMF of the cell or cell potential is the difference is the difference between is the difference between the electrode potential is the difference between the electrode potential of two options, difference between electrode potential of two options, difference between electrode potential of two half cells. Two half cells means the first one cell is suppose this is zinc and it is placed in zinc sulfate solution, and second is copper and that is placed in copper sulfate solution. So and this this both these two cells are connected with the salt bridge. These two cells are connected with the salt bridge. Salt bridge. So here this negative electrode and this is positive electrode, and these both the cells are connected with the voltmeter. So here oxidation, this is acting as anode and this is acting as cathode. In anode, there is taking place wherein 2 plus 2 electron, and here CO2 plus 2 electron. So this is this this half cell is another and this half cell is another, and the calculation of difference between electrode potential of this and electrode potential of this, and the difference of the electrode potential of these two half cells is known as cell potential or EMF of the cell, and this can be calculated E of the cell, that is equal to E cathode minus E anode. E cathode, electrode potential of cathode minus electrode potential of anode, or you can say E of the cell is equal to E right minus E left. E right minus E left means here is cathode in the right side, so E right potential of this electrode minus potential of this electrode at anode. So we can write E right minus E left, E cathode minus E anode. We can say, or we can say E of the cell, E of the cell is equal to E E E of the cell. We can say Cu 2 plus Cu, because we are writing for cathode, minus E of the cell Zn plus and Zn we can write in this system. And suppose E cathode is equal to 0.034 volt minus, and E left at anode, this will be minus 0.76 volt minus 0.76 volt. So that will be equal to 1.10 volt. 1.10 volt. This is the electrode potential of the ganglion cell. This is the electrode potential of the ganglion cell. So, student, today I will discuss about the electrode potential, standard electrode potential, standard hydrogen electrode, and cell potential that is called EMF of the cell, and that is difference between two electrode potential, difference between electrode potentials of two half cells. These two half cells both are connected with the salt bridge. This electrode potential is different, and electrode potential of this is different, and the difference of this the difference of these two electrodes that is called EMF of the cell or cell potential we can call. So that it ends for today, and for tomorrow we will discuss the next topic related to this lesson of electrochemistry according to the new syllabus. And one important information I would like to give you that solid state, the lesson 1 of NCERT books, that is included in the recent years for the syllabus of this session, and the last two lessons of chemistry in everyday life and polymers, these two lessons are excluded from the new recent syllabus. So, after electrochemistry solution, I have taught in e-classes electrochemistry. I am going to finish within 2 or 3 lectures, and after that we will discuss solid states. It is again included in the new syllabus for this session. Thank you.